Hey everyone, today I'm going to teach you guys how to differentiate functions like 5x to the power of 2 or 2x to the power of 3 over 2. Now, these are just simple differentiation, but I'm going to teach you guys how to do more difficult ones later in the video, so stay tuned for that, and let's get started. Okay, so for differentiation, there are multiple rules you have to follow. That being constant rule, that's the first rule. And this is actually the easiest rule because any constant the derivative of any constant will be 0. So you just put 0 here. Now, the next rule, we have power rule. Now, this is also pretty simple because the derivative of, for example, x to the power of n will equal to n times x to the power of n minus 1. So you kind of see a pattern here, right? You bring the n to the front, and you minus the power by 1, like you see here. Okay, next we have the product rule. Product rule, and it states that the derivative of fx times gx. So if two functions are multiplying, derivative of that would be f prime x times gx plus, and then f of x times g prime x. So I'll explain more of this later, but this is what you have to remember for now. And I couldn't fit it in one line because like my writing is kind of big and there's not much space to write it on. Okay, next rule we have the quotient rule. Quotient rule, and it states that the derivative of fx divided by gx will equal to gx times x prime f prime x, my bad, minus f of x times g prime of x, and times gx squared. And I know it looks overwhelming at first, but once I explain this later, it'll be much easier. Okay guys, lastly we have chain rule. The chain rule states that the derivative of an inner function that is raised to the power of n would equal to n. It's because like you bring it down like you did with the power rule. So basically n minus 1, but except now at the end you times it by the derivative of the inner function right here. And I know it sounds like really confusing right now, but when we do some questions of it, it'll seem really easy. And also there are some questions that'll be a mix of like one or two or more different rules, which we're not gonna do today because like we're just trying to understand each rule and the concept of them. So yeah. Okay, let's do some power rule practice. So first, we have fx equals 5x to the power of 6. To differentiate this, we can do this by using a power rule. So f prime of x, or you could also put this as dy over dx, or any other way, y prime, like this all represents the same thing. Okay, so we could use this by doing using a power rule. We move the 6 up to the front, so 6 times 5, 6 times 5 x to the power of 5, because it's 6 minus 1. So let me put 6 minus 1 here so you guys understand this better. So this would equal to 30 to the power of 30 times x to the power of 5. This would be the answer. Okay, next we have this function 2x to the power of 3 over 2. Now this is a little bit more difficult, but it's still manageable because we could do the same thing here. We move 3 over 2 at the front, and we do 3 over 2 minus 1, which is 3 over 3, or I meant 2 over 2, my bad. Now to finish this equation, we do 6 over 2 times x. Now 3 over 2 minus 2 over 2 is just 1 over 2. So is the power of 0.5, so it's basically the square root of x. Now, lastly, we just simplify the fraction, so this is 3, x to the power of 1 over 2. We could also express this by 3 times the square root of x. Okay, next we have this polynomial here. What we have to do is just do the same thing, but since we have a constant here, we have to use a constant rule, which states that any constant, the derivative of any constant would equal to 0. So let's move the 2, so 6x, right? And then plus x minus 1, so that's to the power of 0. And there's no power here, so it's just 5. And then the derivative of 1 is just 0, so we just leave it like this. So the derivative of this polynomial is 6x plus 5. Okay, next we have this polynomial here. It's kind of different because this is the power of a half. So let's do the same thing here. Move the power at the front. So 1 over 2 times 4 is just 2x. Now, this would become a negative power actually, because 1 over 2 minus 2 over 2, which is 1, would equal to negative half. So we just leave it like this. Minus, so the derivative of 2x, if we use a power rule, x minus 1, or this is just to the power of 1, so 1 minus 1, x to the power of 0, times 2, it's just 2, and this is a constant, so derivative of that is 0. So we have the answer here. You could simplify this more if you want, but it's really your choice. Okay, so we're moving on to the product rule. I wrote the rule here, so it's easier to remember. For power rule, I didn't because it was kind of easier to remember. You just drag the power down and you minus 1 for the power. So, for this question, I'm gonna do negative x to the power of 3 times 3x to the power of 4 minus 2. Now, to get the derivative, or y prime, we have to look at this rule here. Fx times the derivative of gx. So we gotta do like a power rule. Like if you know, like, I'll just do it so you guys like would understand it. But it's kind of like power rule and another rule like mixed together. So 12x to the power of 3, or that looks bad, 3, and that's just 0. Plus, so the derivative of that is negative 3x2 times gx, so gx is 3x4 minus 2, like this. Now we just have to expand. So using that, we can do 4, you just do this easily. Negative 12x and 3 plus 3, 6, and then minus, oh, we could do, okay, let me do this in one function because it's easier that way. So minus 3x2, right, and then that would be 9, x2, 4, 6, plus x just times 2, or times negative 2, plus 6x, 2. Okay, now after we expand, or this, negative 6 plus 6x2, we collect like terms, because this is x to the power of 6, so negative 21 x to the power of 6 plus 6x squared is the answer, or the derivative of this whole function right here. Also another one, 2x to the power of 4 minus 3, well that 3 looks really bad, times x squared plus 1. Or that x kind of looks like really bad, but I think it's fine. Y prime, or the derivative, would equal to f of x, so we leave this the same, times the derivative of g of x, so 2x plus 0, plus derivative of f of x, so 4 times 2, 8, x3, then the constant, so derivative of f is 0, times g of x, so x squared plus 1. Now we just expand and collect terms like we did last time. So 4x to the power 5 minus 6x. Now there's no minus here, so I just do it regularly. 8x to the power 5 plus 8x3. Now we could collect like terms right here. So 4 plus 8 is 12, x5, 8x3 minus 6x. So this is the final answer, or the final like derivative of this function right here. Okay, for this next question, let's do something like minus 6x4 plus 2 plus 6x minus 4. No, spice things up. Times 6x4 plus 7. Now I know this looks pretty weird. I'm gonna make it separated so I don't get mixed up here, but it's just the same thing. Derivative of this function will just be fx, so we just do the same thing. I leave this the same, and then times the derivative of this. So this will be 24x3 plus 0 because it's a constant, and then plus f of x, or the derivative of f of x. This is what we have to do. 6 times 3 plus 0, and then negative 4, so negative 24 times okay, yeah, and then 6x4 plus 7. Y equals 0, but you know like b, so 4 x 2 over 4, negative 4 x 7 plus 40, 8 x 3, this is what it is, 1.4 x 2, yeah, 4, okay, I think that's 4, 12 x 7, minus 144, so 2, 8, 8 x 7, and then for the x to the power of 3's, negative 168 plus 48, that is negative 120 x to 3, and then it's just this after. So this should be the answer. This should be the final answer to this function right here. The next row, we have quotient row. So we're gonna do this equation here. Y equals 2 over x plus 1. Something easy for now, but it's gonna get hard real quick. The derivative, or y prime, would equal to gx times f of x. So gx would be x plus 1 because it's the one below the fraction, or the denominator of the fraction actually, times f prime of x, so that's just 0. We have a constant here, which is really helpful for us because it's way less math and I don't have to do more. Times g prime of x, so that will just equal to 1 times gx to the power of 2, so the denominator squared, x plus 1 squared. Okay, let's expand. This would equal 0, so we just ignore that. Negative 2 times, or over, x plus 1 squared. We could leave it as that, or we could expand it, but it's up to you. Or yeah, I'm just gonna leave it as this because it looks right and it's basically the right answer. No further math needed for this, so yeah. The next one, the numerator or the denominator isn't a constant anymore, so it's gonna be a little bit more difficult. It's still manageable, so we're gonna do y prime equals gf times the derivative of fx, so gx here. The derivative of f of x is this, is, just power rule, minus 7 minus f of x, so we leave the numerator the same, times derivative of gx, so g prime x, that will equal to 10x, and this is a constant, so we ignore that, or it will just equal to 0. Now this line looks really sloppy, I tried my best. 5x2 plus 2 squared. We usually ignore this and just make the denominator the same because it's already factored, so there's no point of really expanding it. Okay, that looks really bad, but we're gonna collect like terms. So we have 2x to the power 4s here. Now 60x minus 40x is just 20x. 4. We have 3 to the power of 2s, so 24 plus 70 minus 35 is 59 plus 59 x squared and minus 14. Now we can't forget the denominator. I actually almost forgot the denominator. So, yeah. But the final answer for this is this this long expression here. So, I think this is about as hard as it gets for quotient rule. Let's move on to the chain rule. Okay, guys. So the chain rule is the last rule we're gonna do this video. So let's do a practice question with that. So for this function, we have to find the derivative of this. Now, like the power rule, we still differentiate this part. However, for at the end, you times f prime of x. So let me show you what that's gonna be like. So n, right? So you bring the 4 here. 6x squared plus 7x, and 4 minus 1 is 3, times f of x. So basically just timesing, or I mean f prime of x, so basically just timesing the derivative of what's in this bracket right here. So 6 times 2 is 12, minus the power plus 7. Okay, so f of x, 4 times 12x plus 7, times 6x2 plus 7x to the power of 3. And that's basically it for this equation. Now, chain rule can get much harder than this, like the next example I'm gonna do. Okay, so for expression, we have a polynomial here. And that's timesing, or that's, the exponent is a negative power. So, let's solve this. Now, we know that we bring n to the front. That's just like what you're supposed to do. But since it's a negative power, -2 minus 1 is -3. Now that like tricks a lot of people, so you have to always watch out for something like that. Times f of x, so just I meant not f of x, I keep messing up, but it's f prime of x. So let's do f prime of x here, -3, and that's a constant, so 0. And I'm not gonna expand, because what that can do is like, that could just like waste time basically, because if you leave it as factored form, that's still a correct answer, right? But if you expand it, like, it doesn't really change anything, right? Like, you just add this here. So I'm just gonna leave this answer as it is right here. Okay guys, for the last question we're gonna do this video, we have a square root instead of a bracket and an exponent. So don't let this fool you, because this would just equal to this function, the same thing, but to the power of 1 over 2. And it's the same thing if this is like a third root, right? It would be 1 over 3. So just don't get that messed up. Like, it's just pretty simple. I don't know a lot of people that get like tricked by that, because like we already know that a square root equals the power of 1 over 2. Okay, let's do this question. So write it out. Now this would equal to -1 over 2, so a negative square root, times f prime of x. So that would equal to 26 x minus 5. Okay, now you can always expand this, like, it doesn't hurt to expand, but I'm just gonna leave it as factored form, -1 over 2. Now this is the final answer, but like you could also move this whole thing to the denominator here, but I'm not gonna do that because it's just simpler to leave it like this. Now some teachers would mark this as the wrong answer. Just depends who your teacher is. So yeah. Alright guys, thank you for watching this video. This is the end of all the basic differentiation rules that we're gonna do. Next video we're gonna do something more complex. Also, this is my first time doing a video like this, so I was kind of nervous, but I think it turned out pretty well. I would hope to do something like this in the future again, because it was actually really fun making this. So, yeah, bye guys.